Hi everyone. Now we are going to talk about refraction of light by using Huygens principle. Already reflection we did. So those who have problem with reflection, those who did not watch that, check out the last video. That is reflection by using Huygens principle. Now we are going to talk about refraction by using Huygens principle. So here the diagram that I gave, you know this diagram, you are very familiar with this. But here we are going to make it as a wavefront. So this is the first wavelet. You can see that LA, and this one is nothing but LB B dash. And then what is AB? You are very familiar with this, I guess. This is nothing but, what is this? This is incident wavefront. This is nothing but incident wavefront. And what about the second one? Second one, this one, you can see that. Look at this A dash. A dash, this one is nothing but refracted ray, and B M dash. You can say that A dash L. L is actually L dash is a refracted wavelet, and here B M dash also you can see. And also you can see that here also I am going to draw a perpendicular line which is perpendicular to what? The direction of propagation after refraction. So what is this? This is nothing but refracted wavefront. This is nothing but refracted wavefront. Okay, now let's talk about it. And before that, I would like to give you one idea. That is, this is medium 1, this is medium 1, rarer medium, and this is medium 2, that is denser medium. You know that. Why did I take like that? Because from the figure it is very clear. From rarer to denser, RDT. From rarer to denser, towards. It is not DRA. What is DRA? Denser to rarer, away. It is RDT. Towards. We already discussed in ray optics. I hope so. The thing is, now you can see that the wave front, like look at this, when the particle is at A, but here in the second wavelet it is at B. I hope you understood that idea. Then from B to B dash, this, when the incident ray travels B to B dash, from A to A dash, this one, the refracted ray, the first ray reached. You can see that they are perpendicular, which means what? Look at this, here also they are perpendicular, which means this is correct. A dash, you can say that the distance traveled from B dash, this distance, that is the time taken for that. Or maybe I can call this B dash, how much is that? This is nothing but, let's say in the rarer medium, the velocity is V1 and refractive index is N1. In the denser medium, velocity is V2, velocity of light V2, and refractive index N2. So B dash is nothing but V1 into delta T. What is V1 into delta T? That is the velocity into time interval. The same time interval, this wave, refracted wave, will take to reach from A to A dash. This is supposed to be A dash. This is supposed to be A dash. Okay. So what I can write, how much is this? How much you can give? This is here the velocity is V2. So it will be V2 delta T. So it is very clear. B dash is equal to V1 delta T. A dash is nothing but V2 delta T. Now you can consider the triangles. So I'll be writing it here. So how much is that? B dash is nothing but V1 into delta T because it is in the first medium, and A dash is nothing but V2 into delta T since it is in the second medium. You can consider the triangles B dash, and you can consider the triangle B dash A dash, or A dash B dash. Yes, B dash A dash B. All right. So you can consider, look at this angle. Look, you can see that. Look at this. If this angle is I, everybody listen. This angle is I. This angle, how much? This is total is 90 minus I. So how much is this? This is 90 minus I. This is again I. What about this R? How much is this? 90 minus R. How much is this? R. So that is angle I and angle R are there. So I would like to take, how much is tan I? How much is tan I? Tan I, if you take, no, you can take sin I. Sin I would be better. So how much is sin I? Sin I is equal to, look at this, sin I is equal to opposite side divided by hypotenuse. Opposite side is nothing but B dash divided by hypotenuse. How much? This is perpendicular, so hypotenuse is nothing but AB dash. How much is sine R from the second triangle? From the second triangle, sine R is equal to same. That is AA dash divided by AB dash. So now what you can do, sine I by sine R, you can take. Those who know, they know. Those who know the Snell's law, you know this, how to do this. Sine I by sine R you take. So how much is sine I by sine R? B dash divided by A dash. That is what is sine I by sine R. How much is B dash? You can understand that it is V1 into delta T. So V1 into delta T divided by, how much is A dash? V2 into delta T. So delta T got cancelled. And what will be the value? V1 by V2. This is equal to, how much is V1 by V2? This is N2 by N1. Those who studied ray optics, refraction, they know it very well. So you can understand that sin I by sin R is equal to V1 by V2, which is equal to N2 by N1. This is equal to N21, and which is a constant. So Snell's law of refraction has been proved. So Snell's law is like this. This idea obeys what? Snell's law. Which means what? Which means sin I by sin R is N2 by N1. Which means this obeys laws of refraction as well. Not only reflection, laws of refraction too. So if you are going to derive something, you better get the idea, like what is the final answer that you are going to get, that before itself. If you don't do that, then you will get confused in the end of the steps. Now I don't have any confusion because directly we can make it. So the final result will always give you a clear idea. Look at this. So instantly I started taking tan I. Immediately I thought, okay, this is not tan I. Why? Because in the case of Snell's law, it is actually sin I by sin R is a constant. That is what is Snell's law. This is equal to refractive index. That is Snell's law. But the thing is, if you know Snell's law beforehand itself, then the derivation would be pretty smooth. I hope you get it. And if any doubt is there, means you just ask me.